Okay, hey guys. So for frames, when you're doing this, you normally work with moments. Before you're using axial forces, and that's fine for that. But for here, you really want to use frames, and I'm gonna let's see how I should cover this. You have a cantilever. With changing E and I. Well, it's easier if I say that E is constant and I changes. I think that makes more sense. But yeah, there are cases in industry where you change E. Yeah, we don't need to go into all this detail. Okay, so step one is ignore this. Step one is just look at this. You want to find two moment equations. For delta, okay, so you're gonna apply a you're gonna find a moment equation for this beam. You have a distributed load and a point load at the end. You want to find m of x for this. I'm not gonna find that for you because this is, I don't think you guys do enough work with cantilevers, so solving this problem should be good for you. Then you want to look at this beam. One kip. You want to put a 1. Yeah, you don't put units here. Just leave it in terms of 1. You have a load here. Just know that this is a force. Because if you put units here where nothing else has units, you're gonna be very confused later on. So yeah, just pretend this is 1 for now. And then find a moment equation. Let's call this little m. For this. And you should see that your little m of x why is this taking me so long? Sorry, your little moment of x is going to be let's call this whole thing script L. Oh, the total length is L. So yeah, you have L minus 1x over L. Right, if we have our x going from the left to the right. And you're going to use your work equation, but this time with moments. So your delta is going to be equal to 0L m times m over EI. Then you say, well, but we have changing EI, right? Yes. So you're going to break this up into 2 parts. To 2L over 3 to L EI. And that's for deflection. For rotation, this is for deflection. For define theta, you want to use, this is your cantilever. Use 1. So you want to apply a moment here. Here you applied a point load. You applied a point load here to find deflection. You want to apply a rotation here. You want to apply a moment here to find rotation. So your theta, you're going to get an m for this. And then you're going to use the same thing. We'll call this m theta. We'll call this m delta. Delta, 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 m theta. So m times m theta. M theta. I'm sorry. This is. Oh yeah, 2L over 3. That's right. This is. Over 3 over 2. You want to add this. So yeah, so this is all you do. I think number 5 is actually one of the easier ones to do. It's easier, but it's also more important, probably. Yeah. Let us know if you have any questions with number 5. Number 6 is very similar. You want to find the moment that develops in here. Yeah, I'll probably do a separate video for number 6 actually. But yeah, let us know if you have any questions about number 5.